Alright, I want to take a look at the graph of the secant now. Again, I'm going to think in terms of stuff I already know. So I'm going to think of the secant as 1 over the cosine of x. Secant of x is 1 over cosine of x. And I know what the graph of the cosine of x looks like. So in blue here, I'm going to do the cosine curve. Starts up at 1, goes down to -1, comes back up to 1. That was 2 pi right there. So pi was right here. And it does the same thing on the other side. Right? And of course it continues on. But, so what does the secant do? Well, thinking in terms of numerator and denominator here, the secant will equal 0 whenever this numerator is equal to 0. But I don't know about you, but I can't think of any times that 1 is ever equal to 0. So this graph is never going to hit the x-intercept because that numerator is never 0. However, the denominator does equal 0 from time to time. Cosine x is equal to 0 right here and here. Well, that's going to create an asymptote for the secant, right? When trying to divide by 0 is going to create an asymptote. So in red here, we'll do the secant. So there's going to be an asymptote right here. There's going to be an asymptote right here. Whenever the cosine is equal to 0, the secant will be undefined. And as the cosine goes close to 0, the secant is going to be headed up towards, excuse me, towards infinity or down to minus infinity. Now another thing I noticed is that when the cosine of x is equal to 1, for instance at x equals 0, the reciprocal of 1 is still 1. So the secant and the cosine will be exactly the same right there. Likewise at pi, when cosine is equal to -1, cosine of cosine of pi is -1. The reciprocal of -1 is still -1. And so the secant will match the cosine right there. So this is what I do. At 1, the reciprocal is the same. As the cosine gets smaller, the reciprocal is getting bigger. As that cosine is getting close to 0, the secant is getting close to infinity. As soon as cosine becomes negative, the reciprocal is going to be negative. And this is going to be headed downhill like that. Likewise here, this is headed down. Then the cosine is positive again, so you're up here. When the cosine is little, the reciprocal, the secant, is big. When cosine is equal to 1, the secant is equal to 1. So anyway, the cosine, the secant curve looks something like this. I draw the cosine in there just as a guide to help me put in that red graph, which is the secant. Okay? I will give you a fancier view here, a nicer looking view on the graphing calculator. There's the cosine curve. Notice that one period is just a little bit bigger than 6 there. That's 6.28. That's 2 pi. Let's put in red here the secant function. Secant of x, save it, and draw me the graph, and there it is. Okay. These U-shaped things going up and then down and up and then down. Notice that the period of the secant is the same as the period of the cosine, that it repeats itself every 2 pi. I want to point out that these U-shaped things, some people call them parabolas. They are not parabolas. Parabola is a very specific word, which is a shape that comes from a quadratic function. This is not a quadratic function. This has vertical asymptotes. Parabolas don't have vertical asymptotes. Okay, it's a U-shaped thing up and down. It's a secant curve. Okay. Anyway, secant and the cosine very closely related. They're reciprocals of each other, and their graphs relate that.